So part D of question 1, if I was to work out the whole sector area, that would be a half times by r squared times by theta. So that would be the whole sector area. But we don't want the whole sector. We only want this segment here. So we're going to have to take away this triangle. And the triangle, we can use the area of a triangle formula, which is a half one side times the other, well, they're both 10 again, times by the sine of the angle between them. So that area of a formula triangle is a half AB sine C. And we're using that to work out the area of this triangle. Tap that in and this, making sure your calculator's in radians mode, and that'll give you a total of 25.1 centimeters squared. For part E, I'm doing exactly the same thing again. So the area of the sector is a half times by 6 squared times by theta, a half r squared theta, and the triangle is a half one side times the other times the sine of the angle between them. And putting all that in the calculator or working them out separately, that gives me 3.26 centimeters squared. And the last part, part F. So, I mean, there's a few ways we could do this. I think what I'll do is, one thing you could do is find out the whole circle and then take away the little bit, just like we've done before. Or we could try and figure out, well, this angle here is 7 pi over 4. And so this area for all of this is just a half times by r squared times by theta. So that's the area there. Now the area of the triangle here, well, work out that angle there. That angle there is 360, or 2 pi minus that. So that angle there is just a quarter pi. And so the area of this triangle is a half one side times the other times the sine, oopsie, no room, times the sine of the angle between them. So it would be that. Now we want to do the sector plus that bit there. So if I add those two bits together, I get 111.7 centimeters squared. And so there's multiple ways of doing that, but that's nice because it's different to the others.